last talk of this conference, which is talk about PgBouncer, and it's the second talk about PgBouncer on this conference. Has anybody been on the previous talk that Peter Eisentraut had? Okay, then you will not learn basically anything new because it's still PgBouncer talk. Something about me. First, I work at Second Quadrant as PostgreSQL developer and consultant. I've been contributing a little bit over a decade by now. I wrote a few patches, some of them you might have used. And I'm also sometimes co-maintaining the PgBouncer itself. I don't really do social networks much, so if you want to contact me, you either have to use email or GitHub. And that's about it, I guess. So, what's PgBouncer? PgBouncer is basically a proxy that you put in between your application and the database. And that's basically it, right? So, but obviously, it's a little bit more complicated than that. It does have some knowledge of how the Postgres protocol works. So it knows when you are issuing query. It knows when you are preparing transaction, when you are starting transaction, things like that. And it doesn't do like analytics of the query itself that you are executing. So that brings some advantages and also some limitations to it. But the knowledge that it has, it uses basically to provide some additional features like connection pooling or transparent mapping or routing of connections. The thing why PgBouncer is quite popular nowadays is that it's very lightweight. It's based on event framework called libEvent, and it basically has very similar architecture to, for example, Node.js in this regard. And it's able to handle tens of thousands of concurrent connections without problem on single CPU, which is something that normal Postgres obviously can't do. And it has one interesting, quite unique feature, I think, and that is that it can do online restart of itself. What that means is that it's very common that proxy servers or like connection proxy servers will allow you to transfer the connections between the restarts of the servers transparently, and that's something that PgBouncer does as well. But the unique feature, or one of the unique features, is that it also does transparent movement of connections when you, for example, upgrade the binary of PgBouncer itself and start the new version. The way it works is that basically it starts another instance of the PgBouncer. It communicates with the existing instance or the old instance and transfers all the connections completely transparently to the application to the new instance. And then it continues running, and all the queries continue running on this new instance, and the old instance is shut down. So this particular feature, the reason for that is the PgBouncer itself was developed at Skype, and at Skype the downtime requirements for database were basically zero downtime at all. So they didn't want, or we didn't want, because I used to work there, we didn't want operations like upgrades of the proxy server to cause any kind of downtime. So it can do that without downtime. But anyway, the common use cases for PgBouncer is you can lower the number of actually active connections in your database. The way that it does it is that usually when you connect from the application, not all the connections execute queries all the time, right? They are idle some of the time. So what PgBouncer does is that it has several pooling modes where in some of them it is able to give server resources to the connections only when they actually need them. And that lowers the concurrency exposed to Postgres, which improves latencies and throughput of the database itself. It also helps with management of configuration of connection strings. If you are running multiple databases, you don't have to, your application doesn't need to know everything. And if you move something from one server to another, you do failover and things like that, it can be handled transparently to the application without having to change the configuration of the application, without having to deal too much with failure modes and things like that, because the PgBouncer will deal with that by itself. It's often also used for basically same reason for failover handling, but it can't do it by its own because it doesn't do any kind of active checking of if the server is up or not. It expects some external tool to do that. So if you have, I don't know, HA set up with Rep Manager or with Patroni or something like that, it integrates very well with those tools because all the configuration is changeable online. So you just write some trigger script in those tools that update the configuration of PgBouncer and switch, and the applications are moved to the new servers. And there is also a specialized tool called Rebouncer that was written by Magnus Hagander, who is a Postgres committer, which basically is just a simple tool that adds these active checks, and you just give it some configuration, it does active checks, and if it finds out that the master server changed, for example, it will automatically reconfigure PgBouncer. So you don't have to have some external tooling. You can run this next to PgBouncer on the same server in the same directory, and it will take care of automatic reconfiguration. And my favorite feature, actually, because pooling is boring nowadays, and most of the time, languages like Java often provide good enough pooling internally. So there is less need for pooling than it used to be when everybody was developing PHP web applications, is the help with online maintenance and online upgrades. And I will give an example of how that's done at the end of the talk. But let me talk more about the actual features of PgBouncer first. So I was talking a lot about pooling. So PgBouncer has 3 built-in pooling modes. I think 2 of them are actually useful. And so I will only mention those 2. The first one and the default one is session, which basically doesn't really do any pooling. It just maps the connection to PgBouncer from the application to connection in the database. The reason why this one is the default is that it's completely transparent. You can do anything in the client that you would do against normal Postgres. And this is exactly useful when you want to centralize your connection management or help with keeping the downtime small or non-existent during the maintenance operations and upgrades and things like that. Yeah, and then the other pooling mode is transaction pooling mode, which basically means that each connection to the PgBouncer only gets corresponding connection to Postgres if it is inside transaction. So you start transaction, you get connection to the server. The moment you commit, the connection to the server is kept by PgBouncer, but it's usable by other clients at that point. This obviously isn't fully transparent, because if you use session level variables, then those are randomly distributed to random connections. So you have to take that into account. Currently, it also can't do prepared statements. It can do the unnamed ones or anonymous ones, which you use just for variable replacement as a protection for injections. But it can't use the named ones that exist across transactions and help you with lowering the planning overhead, which is usual problem for people who use JDBC, because that defaults to this. It's possible to turn it off there, but in many applications it causes performance degradation, obviously. I'm getting ahead of myself, but it's actually something that we finally started working on. And this is exactly very useful for lowering latencies and increasing throughput of your database. So how do you configure this? There is the PgBouncer uses standard ini file as a configuration format. It's usually in etc PgBouncer PgBouncer.ini. That's where most packages install it. And it contains two sections. One of the sections is PgBouncer, and then there is like the generic configuration, port which it listens to and stuff like that. But then there is the section that's called databases, and that's where you actually manage your connections. The databases section basically contains mapping of virtual databases inside PgBouncer to actual connection strings. So on the left you have like some database name, and if the application connects to the PgBouncer with MyDB, the connection will be actually made to this by PgBouncer, and all the queries will be executed here. And yes?
If you have multiple instances running on the host, so can you specify multiple port numbers?
The connection string can be anything that Postgres supports in the connection string. So port is supported. You can even force username to be used to some connection to use specific user. You can put anything there that like normal Postgres connection allows you to.
And also, if you have more than one read-only slave.
The way to do that is usually via either DNS, that you have multiple IP addresses behind the same DNS name, and then it will do round robin by itself, because PgBouncer has its own round robin algorithm. So if you have multiple read-only databases, you usually want to have same DNS for all of them, and PgBouncer will do round robin. So that's the way to do it. It also allows you to set some of the configuration parameters in the connection string. For example, in the third line, you can see that I changed the pool mode to session. So you can have different pooling modes for different databases if you want to. And it also has one special syntax, which is the star. And it basically means that any database that is not found by the name in this list will be mapped to the connection string used here. And one thing to note is that, for example, if you don't specify database name here, then it will use the same database as what was used by the client. And same for user, same for password, same for everything. You can override user here. If you don't, it will use the one that the client used. Yes?
Would it work with the service option when you set up pgservice.com?
I think that it doesn't work with service option.
I was about to write a patch for that.
Oh, okay. As it does pooling, you can set the connection limits for the pools. It has several options. The usual one that you want to tune is the default pool size, and that's how many connection can single user make to single database. So if you are using one user on one database, you will never get more server connections than what you specify here. But if you have 10 users, you will get 10 times, at maximum 10 times more connections. So if you specify this to 10 and you use 10 different users, you will get up to 100 connections. There is also a special pool that's called reserve pool size, and this is used for when you need to basically handle connection spikes without big increase in latency to the clients. Because obviously, if you get connection that can't get, like client connection that can't get server connection for a long time, it will not throw error, but it will just wait for a while, and the client will see higher latency. So what this reserve pool size does is that when you specify pool timeout, and then the client is waiting longer than this pool timeout, connection will be taken from this reserve pool for this client so that it can actually serve the request. So you can, like if you have some spikes during the day of the connections and you have some available resources to handle those, this can help to actually get over those. And then, since I was saying that the normal pool sizes are per user and per database pair, so you could actually, if you use a lot of users, it could actually explode very fast. There is now also option to limit max connection per database, no matter how many users you use. So even if you had like this set to 10 and you had 10 other users, and it would mean that it would create at max 100 connections, you can still set this to 50, and there will never be more than 50 connections per database. There is also same setting for max user connections, so that one user can't do more than a specified number of connections. One thing to note again is that the default pool size and the max DB connections can be set per database and globally, so you can do tuning as much as you need. You had some question?
Yeah, so a couple of questions. What is the downside of allocating more default pool size of client requesting for any 1,000 concurrent connections on the database?
So there is separate option for actually client connections, and that usually can be much higher because PgBouncer will queue those connections as they are incoming and only give them access to the server up to the pool size. And basically the pool size, that's something that should be or always smaller than your max connections in the database so that you can actually make those connections. So what happens is that you have like lots of connections going to PgBouncer, and it makes it kind of tightens them to just the connections that database can handle, and whatever the database can't handle will have to wait a while.
Okay, wait for the queue as soon as it's completed, kind of queuing.
Yeah. I will show a bit of diagram or animation how that works internally, so that will be more understandable.
So no matter how, in case app has like 10 applications and they have their own pool, each application has 10 connection pool for connections, like totally 60 connections, but if you have 6 app servers, it doesn't really matter how much you configure, doesn't have to match.
No, it doesn't have to matter. There is like client connection count that can be different, and you can have thousands of connections that end up being tens of actual database connections. That's one of the like power of the PgBouncer actually. I mean, the environment where I used it first time was the database had about 500 connections limit, but the PgBouncer had actually 15,000. And so that kind of stuff works. The PgBouncer also provides some authentication. So there are two levels of this. One is the authentication of clients that come to the PgBouncer, and then there is the authentication of PgBouncer itself to Postgres. So clients can be authenticated using basically standard PGHBA. There are some limitations to it. It doesn't currently support LDAP or PAM. It supports only MD5, password, and things like that. And there are additional configuration options, and there is more, but the current, or something that I would recommend to use is PGHBA because it's basically the same as Postgres. So that makes most sense. And then PgBouncer uses, or traditionally used, file of which listed usernames and passwords to authenticate against Postgres. In the newer versions, that was replaced with mechanism where you just specify one user which runs query that loads these users and passwords from the Postgres catalogs, and then it loads the list of users that it can use to access the database automatically. But the traditional method that's actually still used by most people, as far as I know, is to build your own file and with the mapping of usernames and passwords. It also supports TLS, and again, it supports separate TLS configuration for the clients coming to the PgBouncer and separate TLS configuration from PgBouncer to the Postgres actually. So you can have different CAs, or you can even have TLS only from the clients but not to the server. So it can act as a TLS terminator. So there is like varied options that you can use depending on what fits your use case. Any questions to that? Guess not. PgBouncer also provides some monitoring and administrative commands using a spatial database that's called PgBouncer, unsurprisingly. So when you connect to PgBouncer as a Postgres client with pSQL or application or something like that, it's basically completely transparent and goes to the actual Postgres. There is one exception, and that's if you use DB name PgBouncer, then it connects to this kind of fake database that lives inside PgBouncer and which supports some special commands that you can execute as SQL, but they are not quite SQL. There are some administrative commands like reload for reloading config, or pause and resume for pausing connections and resuming them. It also provides some monitoring information where you can show connected clients information. You can show active pools of the database and user pairs. You can show some statistics about the execution of the queries and like how much connections, how much time is spent on individual connections and stuff like that. The output of that looks something like this for show pools. There is like, for each pool, it will return one row. As I was saying when I was describing this default pool size, pool is basically a pair of database and user. So this record is for database MyDB and user foo. And then it uses then it shows some information. I will skip to bottom. It says that pooling mode for this pool is transaction mode. So it's not the session one that's fully transparent, but it's a transaction where it actually it maps multiple client connections to fewer server ones, and only when they are actually doing something. And it uses this naming scheme where client means the connection from the application to the PgBouncer, and server means the connection from PgBouncer to Postgres. And so you can see, for example, you have 86 connections from the clients, but only one active connection to the server. And then there are 4 connections kept idle for use by the other requests that will be incoming. And the other stuff is not very interesting except for the max wait and the CL waiting. The CL waiting means that is basically the amount of connections that are client connections that are waiting to get server connection. So if you have this like high number, it means that your pool size is too small or that your database is too slow. And the max wait says how long is the oldest client waiting in that queue. And so this is something that if you use PgBouncer, that's the first thing that you should properly monitor because that will tell you that you are overloading your database or that you have misconfigured your pool sizes. Okay, so I was promised that I will explain a bit how this actually works inside. So we have application, PgBouncer, database. The application sends some query. That query or that connection is enqueued inside the internal queue of the PgBouncer. Then the connection has to wait for pool to have some free connection to the server. And this can be immediate if the pool is not full, but it can wait up to whatever timeout you specify, basically. And most of the magic actually happens in this step. Like all the transaction pooling happens here, or if you do some advanced connection management stuff, that also happens here. So in this step is the magic step where most of the processing in PgBouncer actually happens. Then once it actually gets the connection, then it maps the client connection to server connection and then executes the query on that server connection. Once it gets reply, it queues again the reply, because the whole PgBouncer works as a event processing, so it basically circles across the events all the time. So even the reply still gets queued inside the internal queue. It's eventually mapped to the client connection, and the client gets the reply. And that's basically how it works. It's standard event processing proxy. The one thing is, if you look at those pictures, I basically keep oh, it's too much. The one thing that's constant on all of these is that the client connection stays open and the server connection stays open, but they are not mapped to each other all the time, only as needed, right? Skip. One more, and one more. So something about performance of the transaction pooling. I just used simple PgBench, which is not very, well, it doesn't map very well to actual use cases, but it maps very well actually to PHP use case, but probably not so much to Java or Python or something that actually has proper pooling by itself. This is PgBench that runs against localhost Postgres on port 5432. It runs for 10 seconds, standard query, and there is some latency of 13 milliseconds, and it does only like 76 TPS. That's on my laptop actually. I ran this in the morning. And then with PgBouncer in the transaction mode, that's the 6432 is the default port that PgBouncer listens on. You can see that the latency went down because the connections are not established on the server side all the time, and the TPS went very much up because, again, it doesn't spend so much time. And this, as I said, this maps very well to PHP. It maps much less to something that actually has pooling, like most useful languages, I would say. But then if you have, what it helps with is that if you have multiple app servers, which most people actually have, is that if all of them connect directly to the database, you sometimes have to fiddle with the sizing of the pools of those app servers. While if you let just the pooling to run on full speed, you would kill Postgres very often. Or you will not get performance because you set it too low and stuff like that. If you go through single PgBouncer like this, you can do the pooling on the PgBouncer side and don't care about that much on what's happening on the application side, and let it connect more connections that Postgres would handle, and leave PgBouncer do its work, because then you will still get very low latency. I didn't show the negative performance impact that it can have, and that is obviously that you can have one more network hop, although many people run PgBouncer directly either on the application server or directly on the Postgres server, which adds almost nothing. Again, PgBouncer is quite lightweight, it's quite fast, so it doesn't really add much. There is some processing, so if you, for example, do single connection and then select million rows, it will take a bit longer than without PgBouncer, because there is not much overhead for connecting, but there is a lot of overhead for processing the data. That impact is much smaller than the gain usually. I wouldn't use this for, like, if your main use case for your applications was large OLTP queries, you would probably not see much impact. So you would mainly get the benefit of central connection management, and you wouldn't get all that much benefit of performance. But if you have OLTP database, it's very often seen. And you can check web. There is like several blog posts and articles about how PgBouncer improves the performance of applications. I wanted to include the graph that is most famous from Last.fm, but I realized that it's like 8 years old now, so I was thinking like that's probably not something to show in the conference in 2016 anymore. But there are a lot of those. So I was saying that I will talk about one of my favorite use cases, which is the online upgrade. So very shortly, I will go into that. My favorite way of doing online upgrade is using logical replication. I don't know if anybody of you been on my PG Logical talk, but that was one of the main use cases why we wrote that. So what I'm going to tell you about is like how to do that with logical replication plus PgBouncer. And I will be very brief. There is actually quite nice article by Depeche. I don't know if you know him. He is author of this explaindepeche.com, which many people use. His blog is also on Planet. He wrote a couple of weeks ago very nice article with tutorial about how to do zero or almost zero downtime update or upgrade with PG Logical. So I recommend that. But so how you do it with, or what's the point of actually using PgBouncer in here? So I will go through a few steps and then explain what PgBouncer brings in here. So first you would obviously set up the logical replication between, let's say 9.5 to 9.6, either with PG Logical or other replication solution. It's not the only one available there. What you would do then is wait for it to catch up. This is query that works with PG Logical. It's the same one as you would use for monitoring of the physical streaming replication. You basically check that the diff between what's written on the subscriber is and what's written in the local machine is 0. And once that happens, what you do is you modify this databases section of the PgBouncer, where you basically change the host name from the old one to new one. It's still quite obvious. And then the magic, that's like why I like PgBouncer kinda, is this. And that's something that will need a bit of explaining. So you connect to this special PgBouncer database, and then you can issue some commands. One of those commands is pause. And what pause does is that if you remember, I had this diagram with processing of the query, and there was this waiting happening. So what it does is that it pauses this processing of this waiting part. So first it actually lets all the transactions finish that are already active. But once you start new transactions, it will pause them in this waiting mode, and those transactions will not get any errors, but we'll just see that the query is taking long to process. And once all the transactions finished, this command will return. And you are getting queued the new ones, and the queue is getting obviously larger, but since PgBouncer can handle tens of thousands of connections, it will hopefully survive for a while. Then you do reload, which basically internally changes this connection string. So all the new connections that will come for your DB name will go to the new host name. And when you do resume, all those connections that were waiting here will get new server connections as fast as possible. Obviously, it still obeys the pool sizing and stuff like this. So in practice, what happens, unless you have really long running transaction, that's something that takes hours or something like that when you do this, then what happens is that your application basically sees for a while increased latency in the responses, but it basically doesn't know that anything else happened while you upgraded your database to different major version of Postgres. And this technique can be done also for some plant maintenance, where you do switch over to standby, shut down master, and do some stuff with it. If you do it with this way, again, application doesn't need to know about it. And that's like, it's usually much better to have increased response time for a couple of seconds than clients getting errors on their requests. So, and that's my main, that's the feature of PgBouncer that I actually like most. And that's enabled by the fact that PgBouncer actually reads the protocol of Postgres and knows what's happening on the line, even though it doesn't know what the queries are doing. Okay, so that's about it, mostly about PgBouncer. I also want to mention a bit about some possible alternatives to this. So one of them is PgPool. And PgPool has a bit different philosophy than PgBouncer. PgBouncer tries to do minimum useful pooling as fast as possible with very small code base, very small memory and CPU footprint, and be very simple. PgPool tries to do a lot of stuff. It tries to do replication, automatic load balancing. It does many things, and it actually does scan actual queries and tries to interpret them, what they are doing. So then it can actually automatically send you your queries to standby if they are read-only. Obviously, there is no 100% way in Postgres to tell if the query is read-only, because if you do select function, you don't know if the function is if the function does any writes or not when you are processing the query. So there are some limitations to it, but it has more features. It's because it has more features. It's obviously more complex, and all the connections consume more CPU, more memory, things like that. My personal experience with it is also that it's less stable. I actually never been able to run it without crashing it, so that's why I prefer PgBouncer. But I know about a lot of people who actually run it successfully, so I guess I must be doing something wrong, or maybe I just use too big load or something like that. But it's a viable alternative. Then there is something that's called HA proxy, which is basically generic TCP proxy that can do like load balancing and automatic health checks for HA and stuff like that. But it can't do any of the magic that PgBouncer or PgPool do, because it works on the TCP level and doesn't know anything about Postgres. What I've seen many times is that it's actually very useful in conjunction with PgBouncer, where the HA proxy provides the automatic routing for HA, while the PgBouncer provides the other magic and pooling and stuff like that. Obviously, more components you have, the bigger increase in latency, but both of these are actually quite fast. So if you don't have network in between, but run it on the database side or run them both on the same host, the added latency is very small. Also, since I'm a maintainer, I have the advantage that I can talk about what's being in development currently. So I committed about a few weeks ago support for PAM authentication. So that's no longer going to be a limitation. I actually do plan to release PgBouncer 1.8 around the end of the year with this. Also, my colleague Cedric is trying to develop some support for each XA, like external transaction management. What it means in practice is that it should be possible to basically save transaction, disconnect, reconnect, and attach to the transaction that was saved before by using some transaction ID specifics and stuff like that. That's relatively specific use case. If you don't need it, you don't care. If you need it, you really care. And it's not very well supported by Postgres directly, so there is some PgBouncer stuff, some PgBouncer magic again that's being developed. I know that Cedric is actually testing it now in production actually already, but the patch wasn't yet committed. And the probably most important thing is that after years of user requests, Marco and me finally started working on the prepared statement support in the transaction pooling mode. And that's probably the biggest pain points for most people. And I know a lot of users who would really love to use PgBouncer, but basically can't without this. So that should be out soonish. I can't give you exact timeline because most of the PgBouncer work is actually evening stuff. Nobody's getting paid for it, so but it's going to happen because we already have some prototype working code, so it should happen relatively soon. Yes?
How's it going to work?
It basically keeps its own map of cached plans and can reuse the prepare on new connection if you connect to different connection. So you will get some. So if you have high usage of the similar plans, the performance impact will be 0. If you have very varied plans for each connection, you might actually see that you didn't gain that much with the plan caching. But in most cases, it should actually work mostly fine. Yes?
For an environment with LDAP authentication, what would be your suggestion?
With what?
LDAP.
LDAP. Well, for LDAP, you can use the PAM, because then you can configure PAM to provide the LDAP, and that will work just fine. That's why we didn't bother implementing LDAP by itself, because it can just use the PAM. Yes?
What are the advantages and disadvantages of running PgBouncer on the same server?
Yeah, so that's discussion for a couple of hours probably. So there is like, some people put PgBouncer on the application server side, some people put it somewhere in the middle, some people put it on the database side. A lot of people actually put it on both application side and the server side, which is what I usually do. So running it on the database side obviously means that you have just one PgBouncer for the database, meaning that you don't have to manage multiple configurations as opposed to having it on the application side. On the other hand, if you have application, again, PHP, that does open a lot of connections, it helps much less because you still get all the TCP overhead of opening connection over network. While if you would put it on the application side, then the connections only happen on the local host, and that's much faster. Then it will keep the network connections open. So it really depends on your application. If you have something that already does some kind of pooling in your application, like JDBC does, or Go, or Python, or anything like that, then it's usually better to put it on the server side, or somewhere in the middle if you have multiple servers, because then you actually want to often manage all the connections via PgBouncer. Then if you want to have it not to be single point of failure, you probably want to have multiple PgBouncers and have something like HA proxy in between and things like that. So the setup can become quite complicated in production, actually. I've seen applications where there were 3 layers of PgBouncers, so
So in the case of JDBC connections in the session mode, you experience what?
in that case, I would put it either on separate server between the database and application, provided that you have multiple databases that you want PgBouncer 2.2, or on the database server. Yes?
I'd love to take this and self-promote, but I made a thing called PgBouncer wrapper, which lets you access the show commands with where clauses.
Oh yes, that's actually a very nice thing. It lets you to do it from the, like foreign data wrapper directly from SQL. Yes,
Yeah.
That's something that I recommend showing. Yes, recommend checking out if you are using PgBouncer. It's very nice. It's a very nice tool for monitoring because it gives you because as I showed the monitoring in the PgBouncer, it's basically some custom show commands. But what David did is basically he wrote custom foreign data wrapper where you get these exposed in your database as a tables. And then you can just do standard selects on top of them, and that improves the monitoring quite a lot.
Short correction, that was mostly Peter Eisentraut's work.
Oh, okay, that doesn't matter.
No, I don't want to take credit, I just bundled it up and it's on GitHub.
Okay, so check that out. Yes?
Does PgBouncer caching DNS records?
Yeah, so PgBouncer actually does quite a bit of DNS magic if you want it to. It has its own round-robin algorithm. It has actually 2 that you can pick between. It says either LIFO or actual round-robin. And the other thing is that it uses its own DNS cache and its own TTL limitation. So it can ignore whatever the TTL, the DNS server says, and you can set your own small TTL so that you can use for normal applications. Your DNS server will not be overloaded because you will have a high TTL, but PgBouncer will, for example, do a check every 1 second, and then if you do HA via DNS, PgBouncer will actually act very nice with it. It will, that if it detects that the old IP is no longer in the DNS response, it will close all the connections, and the clients that were connected there will be transferred to the new IP addresses.
So the configuration is
on the PgBouncer. And yeah, and this is actually how quite a few people do HA, including Skype with PgBouncer, that they change the DNS and have very small TTL in PgBouncer, and they basically switch the connections via PgBouncer transparently to the application. Okay, so I guess that's it from me. The PgBouncer is on GitHub. There is both website and repository, and there is also chat on Gitter, where actually Marco sometimes links, and you can talk with him and the other people actually as well.